Awesome, thanks. Yeah, so as the alternate title may suggest, while this certainly can be made to work, a lot of the tools that I've used in trying to migrate these pipelines are, to put it politely, terrible. But they're getting a lot better. And so we'll talk about both like where it is today and where it can be hopefully in the next release, although the current release candidate fails to install. So that's where we're starting from. So I'm Holden. My preferred pronouns are she or her. And I work mostly on open source. I'm on the Spark PMC, which means I've spent way too much time thinking about Apache Spark. I'm a co-author of Learning Spark and High Performance Spark. I think you should buy several copies of those books. I like money. You can follow me on Twitter. I do code review live streams if you're sort of interested in seeing how Spark is built. And I also, I give less talks than I used to, but I still care about the feedback. I still want to make them better. So if you have suggestions, just please feel free to give me some feedback here. And so the other part is not so directly related to software, but I'm trans, queer, Canadian. I live in America on an H-1B work visa that expires in January, February, March, April. And I'm part of the leather community. And now, so this is not so directly related to software, yes. But since we're talking about machine learning, I think it's important that we try and have diverse communities that are building the tools for machine learning and machine learning pipelines and things of this nature, since otherwise we'll do terrible things and we'll just make the world a worse place. And the first thing we need to do to make sure that we have diverse communities is talk about where we're all from, and then maybe we can look around and realize like, hey, what's up? This project that I started with my 6 friends from school, we all sort of have the same background. Maybe we should go and get some other opinions about the impact of this from some other people who might be affected. Cool, so there's one person who agrees, and the rest of you are less on board. And that's fine, that's fine. Okay, so our players are Spark, Kubeflow, and Tensorflow. We're gonna talk about why you wanna do this. We're gonna talk about how you can make this work. And then I'll talk about why you might not wanna do this and some of your alternatives to what I did. And there's no demos because 0.7 RC1 broke everything. 0.7 RC0 also didn't work exactly, but it broke differently. And to make this work, you actually need to go back to 0.6.2, which is now also broken. It used to work, but the APIs it depends on are no longer the same. So the yay software. Okay, so it's Spark Summit. Is there anyone here who is new to Apache Spark? Anyone? Yay, okay. So I'm not gonna point you out, but I'm really excited that there are people who are new to Spark here. And so Spark can do all kinds of things, and it does have machine learning tools as well. And we'll talk about why we might not wanna depend on just those machine learning tools and why we might wanna augment them. Cool. So, TensorFlow is fancy machine learning, also known as, hey boss, I need 6 months to go and add deep learning to our product. Please don't ask any questions. In San Francisco, you can raise money by saying that you use TensorFlow and a proprietary data set. Often your data set fits in memory or on a floppy disk. But if you don't tell the investors that, everything's fine. Okay, that's a joke. Thank you for laughing. Okay, and so it has more deep learning options than are inside SparkML, right? Like you can technically build neural nets in SparkML, but you might not want to. Hey, the person in the back, the little timer thing isn't moving forward, so if you could make the timer work, that would be really cool. Otherwise, YOLO, whatever. Cool. Okay, so what is TensorFlow Extended? So after TensorFlow sort of got released into the world, people realized that it turns out that most of our problems are not actually cool deep learning problems. Most of our problems are making our data set clean enough that we can do cool deep learning on top of it. And so TFX has a whole bunch of things to do data cleaning, data prep, model serving, all of the sort of things that you need in addition to just like your fun deep learning problem. And unfortunately, it also has this property of having some challenges in what's called the working department. And so it's really great if you're on GCP. And I used to work for Google, so that was pretty cool. But I don't anymore, and so it's not as useful to me. And so we can use TensorFlow Transform for data prep some of the time. But right now, realistically, we probably just want to use Spark for our data prep. In the future, we might be able to use TensorFlow Transform on top of Spark, but if you try and run that today, that's just segfault city, which is really exciting when you're writing Python code. You can get a native segfault wrapped in a Java stack trace, wrapped in a Java stack trace, wrapped in a Python stack trace, wrapped in a Java stack trace, wrapped in a Python stack trace, also known as, oh dear God, I'm not using this. Okay, so what is Kubeflow? So Kubeflow, very unassumedly, says it is the machine learning toolkit for Kubernetes. That could be true. And it provides a buffet-like collection of ML-related tools. And just like at a buffet, you might not want to eat everything, right? If you try and eat everything at the Hilton breakfast buffet, you are going to get sick. And if you try and use all of the tools in Kubeflow, your pipeline is going to get sick, and it will be very sad. It is also very, very unstable. See my previous comments about how this used to work on 0.6.2, which no longer functions, and 0.7, RC0 and RC1 don't work. That being said, this instability will too pass. There was a time when Spark was as unstable as Kubeflow is today, right? That's just the evolution of software. And they're aiming for a 1.0 release. It's scheduled for December, but I think Q1 might be a more realistic expectation. And hopefully by then it becomes much more stable. But like, please don't use Kubeflow in production today. That's just going to be a bad time. Unless you were looking to find a new job. It can be a very exciting way to find a new job. OK, so why would we want to augment Spark ML, right? Why aren't we just using Spark ML itself? So it doesn't have a huge variety of algorithms, and linear regression is no longer cool. You just can't go to venture capitalists and raise money with linear regression anymore, right? So that's why we have to use deep learning. Thankfully, we can still recreate linear regression inside of TensorFlow, so everything's fine. Okay. Serving Spark models is also what could be described as painful, although there's been a lot of interesting work at making this better. But you might want to like use something a little bit easier. And the other thing is like we can just like essentially tell our boss we have to rewrite everything from scratch, and this can be a chance to fix a lot of other unrelated problems, right? Just like things where we realize, oh, hey, what's up? This field is null half the time. Maybe there's something going on there. And so that could be another reason. OK, so how could we do this? We could install Kubeflow. We can take our Spark job, split it into feature prep and model training, and then we can have our feature prep stage save the results in a TF-compatible format, create a TensorFlow job, create a Kubeflow pipeline to schedule all of these things together, and then use Katib to do hyperparameter tuning. And one of the things that we could check is if our new fancy deep learning model is any better than linear regression. Now, checking that can be depressing, because sometimes the answer is no. So if you don't want to know, skip the last step and just deploy to production. OK, cool. So what is the catch? This is very, very alpha software. Kubeflow had Spark integrated in 0.5, broke in 0.6. I have a PR to add it back in 0.7, but 0.7 doesn't work. And so you can make this work if you like check out very specific Git hashes, which is totally how you want to deploy to production. So yeah, don't do this. This is like professional drivers warning that you see in the television commercials, except replace like professional driver with like drunk software developer. Do not use this in production. So That being said, with all of those warnings, how do we use this in production? We go ahead and we can download KFCTL from their releases. I recommend the latest release candidate because maybe that works. Maybe. Then we go ahead and we download a config file. Now we have to download it from this other repository. Ignore the config files that are in the main repo. They will not, well, I mean, neither of them will work, but the one in the main repo will really not work. Okay, then, because we're doing things on Kubernetes, we get to edit YAML files. I'll show you later, like, I know we're all very excited. Then you go ahead and you point this to a pull request that I've got. That's a sign of quality software development. And you also put in an app name, and then you run a magic incantation and receive software. Maybe. OK. So what we're going to do is we're going to go ahead and we're going to tell it that we want to install Spark. Spark itself is like there. It's just not installed by default. So you edit your like config file to say like, hey, what's up? I actually want to run Spark. Then we go ahead and we set our email address. In this case, I'm using Boo's GCP account because I don't know, whatever. And we set a project name and a zone. And this is if you're deploying on GCP. If you're not deploying on GCP, you can leave out the email, project, and zone. And instead, you'll pick a different config file, and then it'll just deploy on top of vanilla Kubernetes. And so that's convenient. And then, so we run this magic incantation. Oh, damn it, that should say mkdir. Damn, fuck. OK. Well, if you ran this, it wouldn't work anyways, so there's that. Or actually, it would sort of. Right. OK. Oh, yeah, it's also going to create a whole bunch of files under your /temp directory, and if you delete them, it stops working. So that's cool. And when you run this, it takes about 30 minutes. That being said, it does not tell you that it's done. It just takes 30 minutes. And if it doesn't work, there's no error message. But if it works, that's not so bad. OK. Yeah, and the -v is because if you don't run it in verbose mode, it behaves slightly differently. So please run it in verbose mode, because that's the only way it works. Oh, God. OK. So, OK. So what are our options now that we've run this magic incantation? So we can use the Spark operator to run our Spark job, or you could be like, you know what, Holden, this sounds terrible. I don't want to do that. And then you can just use Helm to install the Spark operator like a regular person, let's say. And then we can go ahead. We could also, it packages Jupyter. So we could go ahead and we could add Spark to our notebook. The only problem is 0.7 added Istio, and I don't fucking know what's going on with Istio, and this just doesn't work anymore. But if you were on 0.6.2, you could add Spark to your notebook image, and then you can run Spark. And then your production pipeline can depend on untitled IPython notebook _final_final2, and then you can run it. Alternatively, you could wait for the 0.7 release, and then after deciding that you don't want to run that in production either, wait for the 1.0 release. OK, how do we use the Spark operator? It's not too bad, right? It's just some YAML files, pretty happy. Using it in a notebook involves writing a service definition from the notebook and running kfctl apply from your notebook. Totally normal. Totally normal. Yeah. Sure. And then we specify this sort of like minimal, OK, yeah, minimal config. And all kinds of fun. If you disable Istio, it works. But it also, disabling Istio breaks the model serving. So that's not a great solution. But it'll get better. It'll get better, I promise. OK, so as you may have guessed, if we attempted to demo this, there is a 5% chance that I would get it to work. This is based on doing it roughly 100 times. And it does work sometimes, but we're going to skip that because as entertaining as it is to watch me curse at a computer, it takes 30 minutes to deploy. So I've got 18 minutes and 22 seconds left. That's just not going to work out. So, okay, what does our traditional Spark ML pipeline look like? So this is from my code one. I was doing a string indexer on the file extension so that we could map the different code types. And then I had a regex tokenizer for something. Oh yeah, I was extracting tokens with a regex. And then I was doing word2vec, so I had feature vectors. And then I made this like pipeline, fairly basic. You know, I indexed the extensions, I tokenized it, I created a feature vector, and then I trained a classifier on top of it. Yay! Yay! Okay, I'm excited. But so now we're gonna drop the last part, and we're not gonna train our classifier. Instead, we're just gonna take this part and we're gonna save it. We're gonna save the results of doing this. And we've got some options here. We can save in TF record, but doing that is annoying as hell. You have to like check out this repo, check out this other repo, build both of them, publish them locally, and then add them as an assembly to your like Spark job. And like that's maybe not a great experience, one could say. It seems definitely stable. Definitely stable. Alternatively, we could use everyone's favorite format of CSVs. Yeah? Go team. Okay, and so that's what I did. I used CSVs because the other one was way too much work, and I already had enough really questionable code at this point, right? Like, oof. Alternatively, you can see there's pull request number 162 on TensorFlow community where they're talking about integrating Arrow as a feed format, and if they do that, we can feed from Arrow records directly, and our life becomes a lot simpler. If anyone would like to chime in on pull request number 162 and say that they'd love to see it, maybe that can increase the likelihood that this happens. Okay, so making a TensorFlow job that uses our Spark output, this part is, I mean, you can literally just grab one of the default TensorFlow jobs, slap it on the end, and it will kind of work provided you rename the fields. TensorFlow doesn't really care that our output came from Spark, although we will pay for that later when it comes time to serve our model. So we'll look at the pain that's there. And there's the introduction to TensorFlow 2 talk at 4 p.m., right? 4:30 p.m., my apologies, that you should definitely go and check out. That will be a much longer version of this slide. Very fancy. Okay, so check out the 4:30 talk. Okay, and now we've sort of figured out the pieces. We need to put them together so that they run repeatably and succeed 5% of the time. So we're going to run it in a loop. Don't do that. Okay, so there's some documentation on their pipelines, and don't worry, just because it's in Python doesn't mean you don't get to edit YAML files. Everything compiles down to YAML anyways. So we can use Spark. We can use our Spark operator again, just like we did before, or we can use the notebook part. I like the notebook part a little bit more. We'll show some examples. Building a Spark Kubeflow pipeline is relatively simple. There's a few small catches. This is sort of the standard imports for the start of our Kubeflow pipeline. We need to specify our jar location. In here, we essentially have a JSON version of the YAML that you would normally write. Then we do our substitution, we load the JSON back, and then we create a resource app. And we want to make sure that our success condition, we need to specify a success condition of succeeded, because otherwise it uses a success condition of available. And at that point, it just starts running the next stage as soon as your Spark job starts. which will probably not have any data. So we need to specify a success condition, and then afterwards we can run our regular, TensorFlow job. That being said, the TensorFlow job integration into Kubeflow is currently broken. See issue number 677. So instead, you use a container op, and you point it at a container that you roll with your TensorFlow job inside of it. Once 677 is resolved, you can instead directly, I'm sorry. I don't know. Oof. Okay, right. So maybe you look at that and you're like, you know what, Holden? That sounds like a lot of making containers. I don't want to do that. And I don't blame you. That is not a lot of fun. My life doesn't exist to write Docker files. So instead, what we can do is we can just take our notebook. Hopefully we got it to work, right? We ran it, it works. And then we can make our pipeline inside of our notebook. We have the same imports that I showed you already, and then we add this sort of annotation. The base image, we still do have Docker images, and you just pick the image that you chose when you were launching your Jupyter Hub in the Kubeflow UI, and then you go ahead and we have some boilerplate that creates a KF pipeline and creates an experiment and does a run. And it's all kind of fun. We're not going to run that as a demo either. We will do a live action role play. Who wants to pretend to be a cluster? Okay. I thought that was going to go over a lot better. Okay, well, we'll skip that. And you can just pretend that the demo failed. And that gives you an authentic enough experience. Okay. So now we've done this, we've run our pipeline. Let's say maybe it worked somehow. How do we do serving? Oh dear. So our problem is now that everything is terrible. And specifically, we have a bunch of Spark code that needs to run to do our feature prep, and we have a bunch of TensorFlow code which does our predictions. Thankfully, Selden has this really nice concept of like having a feature prep stage where we just encapsulate it in a Docker container. So all we'll do is we'll take our pipeline, we'll encapsulate it in a Docker container. You could even use mleap to encapsulate it in a Docker container and put it sort of just in the middle here, and then Selden will automatically call that, get the results back of the prepared features, and then make another call to your fancy deep learning model and get the actual results back. This does add some RPC overhead because they're living inside of separate containers, but it does make it a little bit easier if you want to try out a bunch of different models. So that's kind of cool. Alternatively, you might be like, Holden, all of the things that you have done sound terrible. I do not want to do this at all. And if you're saying that to yourself, I completely understand. I don't want to do this. I have to do this because I am optimistic, I think, maybe. And every time someone publishes a new release candidate, I'm like, you know what? This is the one that's going to work. And then the sadness comes. Okay. So one thing that we could do that might actually even give us better performance is we can integrate We can integrate TensorFlow inside of Spark. So essentially, we can use Spark to feed TensorFlow. With what we've done with Kubeflow, we're essentially writing everything out into a file and then reading it back in. We're using CSVs for data interchange, and that might not be very good. You can also write a bunch of manual UDFs to have the same effect if you don't want to use TensorFlow on Spark. You could use Spark's own deep learning pipelines. Alternatively, you could hope that TensorFlow transform on Beam on Spark on TensorFlow starts working. It doesn't, but to be fair, most of this code barely works as well. So like, bets are out on which one will succeed first. Or you could also just be like, you know what, linear regression is good enough. It's fine. It's fine. Everything's fine. Okay. So some ending notes, in case you haven't taken away already. Kubeflow is pre 1.0. don't replace systems just for the sake of it. I know it's fun, but all you do is you get software that doesn't work. This is one of many ways to do things. It's not a way I'd recommend to anyone I liked or had my phone number. And please be careful with software that you pick to put in production. Okay, that being said, if you are interested in sort of following along as we try and make this less terrible, there's a bunch of resources. There's the pull request to add Spark back into Kubeflow and hopefully fix the bugs. There's some stuff on KF serving, and there's some stuff on Selden. If you're interested in seeing some of the examples, they're in this Intro to ML with Kubeflow / Intro to ML with Kubeflow examples. I need to do a better job of naming my repos, but they live inside of that repo. And they also, the other part lives inside of Frank the Unicorn is the second repo. I should have put that link up there. If you're interested in a book about Kubeflow, which we will write as soon as Kubeflow starts working, you can go to introduction2ml-with-kubeflow.com and give me your email address. And we'll capture the fact that we're in the European Union and only contact you when allowed by law, because I enjoy visits to Berlin. Okay. I have another talk. It's at 3:20. It's in the auditorium. It's about how to contribute to open source, especially Spark. I think that one will hopefully be more fun. You can check out my Twitch and YouTube live streams. I'll be doing one tomorrow at 8 a.m. where I review some pull requests coming into Spark and sort of go, I don't understand what this is. Let's click on that. Uh-oh. And you can join me for that wonderful experience, and then hopefully it doesn't scare you away from doing that. Okay. Here's a bunch of books about Spark. None of the things I talked about are covered in these books, but that should not stop you from buying this one, where I receive much better royalties. You want your Spark job to be high performance for reasons, so give me money. Or actually, give Amazon their money to give to O'Reilly to give to me. And then at the end of that entire process, I can go and buy a quarter of a cup of coffee. Okay, so are you worried your kids enjoy computers too much? Do they think your job is fun and entertaining? You can help teach them distributed systems and disabuse them of the notion that computers are fun and entertaining. Or maybe your children will really like distributed systems. That could happen too. And so I'm working on a book. It's trying to teach distributed computing to children. Unlike everything else, this is not a joke. And I would love your feedback on it. Okay, so I think we've left some time for questions. We can do questions. If anyone really wants to see Kubeflow deployment fail or possibly succeed, I do have my laptop with me, and we can do a Kubeflow deployment if there's no questions. Or if one of the questions is, please show me a Kubeflow deployment. Yeah, I think we definitely have some time for questions and questions. Oof. I could go for a cheeseburger.
Hi, this is Andy from NVIDIA. I have two questions.
Okay.
So first is you mentioned the arrow in the TFX exporter. And I wonder, can you make some comments on the arrow support in Spark and the arrow support in the TensorFlow? Is people hate arrow so much, or just all community needed to work together somehow nicely?
That's a good question. So, I mean, Spark has arrow support built in. The API is to hook up directly putting the arrow output into something other than just feeding it to Python. Don't currently exist, but I think that's because right now there isn't anything else really to feed the output to. If TensorFlow started accepting arrow input, I would be happy to work on those APIs. I don't think there's a large resistance. As we can see, there's the suggestion in the TFX community to adopt it as an input format. And people don't seem averse to it. It's just a bunch of work, and people are lazy. So it'll take time, but if we can make clear, convincing arguments or help, it may take less time. But I don't think there's a strong resistance to it.
Sounds great. I'm going to talk with you later. And then my second question is, you mentioned, so this talk here, you mentioned like a Kubeflow, inside the Kubeflow, you embed the Spark, right?
Yeah.
And then you, as the alternative, you mentioned some of my early work.
Oh, cool.
TensorFlow on Spark. I wonder whether there was actually recent work from Uber team on the Hollow World. And the Hollow World, like logically, you have you like the Spark code do ETL, and then you produce the Parquet data files or data sets, and using the Petastorm kind of APIs to taking the your data sets or your Parquet as the input to your deep learning framework side. I wonder whether you have an opinion on those approach.
So I think certainly writing out to disk in between is not ideal. Yep. Ideally, we could do this in memory. Yep. So I would love to see the Arrow support integrated. That being said, in sort of the medium term, I think writing out to disk is what we have to do if we want to make things actually work in production today. And I think, like we can use Parquet, and then. The nice thing about if we use Parquet is Arrow has integrated Parquet readers, so we can do like sort of a gradual migration of our pipeline if we wanted to. But yeah.
Thank you.
Cool.
All right. Do we have other questions?
Oh, you were the excited one.
I was the one. Yeah.
Yeah. Cool. Thank you for clapping.
Yeah, thanks. It was a really good talk. You're talking about the feature engineering when you run the model, when you're serving the model in Selden being painful because you have to run Spark in a container.
Yeah.
Would it be possible to use koalas to write the feature engineering code in like pandas-like stuff and then run it in pandas in the serving, and then just use koalas to run it on Spark in training?
Totally. That's a really interesting idea. I don't see why not, but I haven't tried to do that yet, and so I don't know why not. But yeah, that would totally be a very good option, I think. I don't know. I also made years ago sparkling pandas, which did an early version of pandas on Spark back before we had data frames. And oh god, that thing was rough. So I am, how would I put this? Cautiously optimistic about using koalas as part of my pipelines. I think it sounds really cool, but I want to try it first and see if it breaks. Cool.
Okay, so let's thank Holden once again and give her a round of applause. Also, please remember to rate the sessions. We're going to start the next session in about 15 minutes.